Good morning and welcome to a lesson on problem solving, dealing with percents. So today we'll talk about types of percent problems where we have just a basic percent problem where the rate times the base is equal to an amount. We'll talk about increase and decrease problems. We'll talk about vocabulary like relative versus absolute increase or decrease, and we'll also talk about percentage point change, which is different than a percent change. So it's a subtle thing, but we'll talk about that as well. So here we go. So first of all, let's talk about this. What is a reasonable tip for a $40 restaurant bill? So this is pretty open to you. Most people tip reasonably. People try to tip around 20%. So about a 20% tip. And you take 20% of the bill. So one way to do that is to take 20%, which is 0.2. You always change the percent to a decimal or fraction form. 20% of 40. Now, a fraction, if you're comfortable with it, 1/5 is the same as 20%. And so you could write 0.2 times 40 or 1/5 times 40. And either way, that's going to be 8. That's $8. And here you could see that you'd reduce those fractions. You could reduce the 5 and the 40 and get 1 and 8 doing that. And then we get, that's 8 over 1, which is $8 also. Now, a quick way to do 20% for a tip is to take 10% and double it, because 20 is just 10% double. And when you take 10% of a number, like 40, to do 10% of 40, it's a real quick way to do that is just to move the decimal point one place to the left, because 10% is just going to be 0.1, which is multiplying by a 1 and then moving the decimal over. So a lot of people just take 10% of 40, which would be $4, and then double it, giving you $8. So it's a quick and easy way to have a tip. So if you've got let's say you've got a bill that's $62.50, a quick way to do a 20% tip is to take $6.25, that's 10%, and double that to $12.50. So this would be 10%, and then doubling it is a 20% tip. And there's no really wrong answer there. It's just a correct way to calculate a percent. So now let's talk about this blouse. The blouse is on sale for 20% off, and then a 10% tax is added after the discount for the final price of the blouse. If the blouse was originally priced at $40, what is the final price of the blouse? So we can pretty quickly do this in our minds, because 20% off comes first, and we just calculated 20% of 40. Since 10% is $4, 20% is an $8 discount. Right? That's 20% off. So it's an $8 discount. So that's 40 minus $8 is going to be $32. So that's our new price. That's the sale price, right? So the first thing we do is we subtract, we get a discounted price. Then on the discounted price, we have 10% onto that. So we take the $32 is now our new base. Now we take 10% of 32, which is $3.20 if we move the decimal one to the left. So that makes it $35.20. So that's a pretty basic percent problem. Now this asks us to identify the relative decrease and increase. So relative refers to either a percent or a fraction of the total. So we're going to write it as a percent. The percent decrease, what is the percent decrease? The relative decrease is 20%. That's given in the problem. The relative increase, that's what's the percent of increase. Well, that was the tax, right? The discount was a decrease. The increase was our tax. That was a 10% increase. Now, what does absolute increase and absolute decrease mean? Well, the absolute increase is, an increase was where we had the tax, and that was $3.20. That was the absolute increase. That's the amount of increase. And then the decrease, that came from the discount, right? The discount was how much? That was $8. So the 20% goes with the $8. The 10% goes with the $3.20. That's the increases. So now you understand the idea of relative increase will be a percent amount, and the absolute increase will be, well, if it's dealing with money, it would be dollars. If it's dealing with people, it would be the number of people. But it's a quantity in the units that you're dealing with. It's not a percentage typically. Now, that's where it gets a little tricky when the quantities you're dealing with are percentages already. And then we'll have an absolute increase, which will look like a percentage point, and we'll talk about that a little later. Okay, the average number of employees in the coal mine production sector in 2009 was 86,859, and that increased to 91,611 in 2011. So, and that information came from the U.S. Energy Administration, their coal report. So it says find the absolute increase and the relative percent increase. That percent isn't necessary. That's just to emphasize what it means. In mining employees for that 2-year period. Well, the absolute increase is the number of people or employees in this case. How much did that increase? Well, it went from 86,859 up to 91,611. So that went up by whatever this difference is, and we subtract that. So the 91,611 minus the 86,859, and so that's just 4,752. 4,752. So that's the absolute increase. I'll just put a plus there. AI, absolute increase. Well, the percent increase would be based on, now this is kind of an interesting thing to pay attention to here. The increase is always based on the previous amount. So the base of this, if you remember, we have the rate times the base is equal to the amount. The rate, that is the relative increase that we don't know. But the base, also known as the before amount, that was 86,859. And it's equal to the amount. Now, remember, if we want the relative increase, then over here, this value has to be the absolute increase. So we have to know, to use this formula, we have to know, to find the relative increase, we have to put in the absolute increase, which is 4752. So I just wanted to note that the rate and the amount should correspond, okay? If this is the relative increase, this should be the absolute increase. If we're looking for a relative decrease, this A should be the absolute decrease. Okay, so how do we solve that? Well, we take and divide by the 86,859 to reduce that and get R by itself. And here we 86,859. And now that's going to be a decimal. To change a decimal to a percent, we always multiply by 100%. Okay, that's how you convert anything to a percent. Multiply by 100 and put on the percent sign. So we get the 4752 divided by the 86,859, and that is 0.054709, and it goes on and on. But if I multiply that by 100%, you know when you multiply by 100, it's just as simple as moving the decimal 2 places to the right. So that's about I'll just write 5.47%, or you could round off to 5.5%. It just depends. It doesn't indicate in this problem how to round, so we'll just do it there. Okay? Now, it says this year the cost of let's see, did I finish that question? The absolute increase. So this, by the way, we should write, that's the relative increase. And we already had the absolute increase was 4752. That should have a dollar sign. That's the absolute increase. Okay, so there's our two results. Or 5.47 if you want to round, take it a little further. Okay, so now let's move on. This year the cost of a cable television is 18% less per month than it was last year. Now, of course, since it's a percent, that's a relative decrease. That's a decrease of $7.20. cents per month. So that gives us the absolute decrease. So we have these corresponding items, the relative decrease and the absolute decrease. So if we use, that allows us to use this formula, R times B equals A, because these two correspond. They're both decreases. One's the relative, the percent, and one's the absolute. So it says, how much per month was the cost of cable television last year? Well, that is the base. That's the before. Last year is the before amount. So the rate of 18% times the base is equal to the amount of the absolute decrease of $7.20. And so in this problem, we're just going to divide by the 0.18 to find out what B is. So we get 7.2 divided by 0.18. So B is equal to 40. And this is the amount before the decrease. Now, it also asks us, so how much per month was the cost of cable last year? That's $40. This is last year. And now it asks, how much per month is the cost of cable television this year? Well, if it went down $7.20, it was at $40. If we take away the $7.20, the amount of decrease, that puts us at 40 minus 720 is $32.80 is this year's. Okay, so there we go. This is this year, and this is last year. Okay, so a bicycle is on sale for 15% off the regular price if sales tax is applied to the sale price at a rate of 8% and the final price is at $110.16. What would the original price of the bike have to be? Well, this is a little trickier problem. When a bicycle's on sale for 15% off the regular price, and notice it didn't tell me the original price, and it actually doesn't tell us the price after the sale. So just to understand that problem, I'm going to scroll back up here and this is when we solve these discount or markup and increase problems. When we don't know the amount of decrease or the percent of decrease, or we don't know the amount of increase or the percent of increase, we can't use this RB equals A. Remember, this R has to correspond with this A. So we've got to know one of those two things, either the rate of decrease or the amount of decrease. And you can see in this problem, it doesn't give us either one. So I'm just going to set this up. We're going to use this formula then. This formula, a decrease would be 1 minus the rate of decrease times the base will be the A, which is the amount after a decrease. So this is not the amount of decrease. This is the amount that you get after the decrease. And this A is the amount after the increase. So if you use the RB equals A, then this A has to be the amount of increase or decrease. But if you use the 1 plus RB or 1 minus RB, that means the A is what you get after it's an increase or after the decrease. So remember, notice here, RB equals A only if A is the amount of increase or decrease. So let's go down to the problem. And I'm going to set it up. This is first, it's a 15% off is going to be a decrease. So I'm going to write this as, this would be 1 minus 0.15, right? It's 1 minus R. Times the before amount should equal the, well, I guess I'm going to change that B to regular price. I'm going to call P. That's the regular price P. And then I'm going to call the, after the discount, this is the D is after the discount. Okay, this will be the discounted price. Right, just like the formula said, after the decrease. Well, the discount is the decrease. And then it says if sales tax is applied, that means you're going to pay more to the sale price. That's the discounted price. If you add something to the D, the discounted price, at a rate of 8%, and then the final price is $110.16. So that tells us that 1 plus, now the tax rate's is 8%, which is 0.08. Now we add that tax onto the discounted amount, and that should give us $110.16. Well, if you notice, this second equation gives us enough information to find D. And once we find D, we could plug it into this equation and then find P. So this equation becomes 1.08 times D, right? Just add the 1 and 0.8, and then divide both sides by 1.08. So $110.16 divided by 1.08 is 102. So D is equal to 102. Now these are in dollars. I should keep my dollars on there. I want to make a point at something out. Why is this 1 plus 0.08 is 108? Remember, the 1 really stands for 100%. So what it means is you're paying 100% of the discounted price, plus you're paying 8% more. So the sale, the final cost, is more than the discounted price, obviously, right? 1.8 more. And that gives us D equals 102. Now when we come up here, we can plug this D into this equation. And of course, what's 1.1 minus 0.15 ends up being 0.85 times P is equal to our D. And so that D we know now, we solved, is $102. Okay, now let's talk about why this is 0.85 here. The 1 minus 0.15 is 100% minus 15% is 85%. That's why we get the 0.85. That means that your discounted price, if you take away 15%, you're only paying 85% of the original price. And now that enables us to go ahead and solve this by dividing both sides by 0.85. And so we'll get P is equal to whatever 102 divided by 0.85 gives us, which is $120 is our original price. Okay. Now this is a similar problem. The total cost of a bed frame that was marked down 20% is $158.36 after taxes. If the tax rate is 7%, what was the original cost of the bed frame before the discount? So this $158.36 is after the taxes. So it comes from, again, the first thing is it's marked down by 20%. So that's 1 minus 0.2 times the original price is equal to the discounted price. That means 80% of the regular price is the discounted price. But we don't pay taxes on the P, we pay taxes on D, which is 7% added on to the price, so that's 107% really, of the discounted price should equal our final price. I'll write this final cost. So that's 1.07D should be equal to 158.36. So now we just divide by the 1.07, and that is 158.36 divided by 1.07. That gives us 148. Okay, a little bit less. And then we can come back to this problem and plug it in for D. 0.8P is equal to 148. So we divide both sides by 0.8. And, well, that's like 8 into 1480, right? We make that a whole number. So 8 goes into 14 once with 6 left over. It goes into 68 8 times with 4 left over. So that should be $185. Okay. Okay. So the community college according to a report by College Board Advocacy and Policy Center, the average tuition and fees for the 2010-2011 school year at public community colleges was $27.13. Okay, so I'm just write that. Community college, CC is $27.13 is for the tuition. And public four-year institution in the state, the tuition fees were $76.05, so that's the 4-year, or $76.05. Those are the tuition fees. So now it tells us that the community college tuition and fees were what percent of the 4-year institution's tuition and fees? Well, this is not talking about an increase or decrease or anything, or it's a strict comparison. And on a strict comparison, you have to determine, we're going to use the R times B equals A formula, but it says what percent of the 4-year institution's tuition and fees. So whatever follows the word of in this type of situation, if you have a percent of something, this is the base. So the base is the 76.05. The percent of is whatever you take the percentage of, that's the base of in the percent. Now, we want to know what the percent is. That means we don't know what the R is. And it says the community college's tuition and fees. That must be the amount, the $27.13. So we can go ahead and take that and divide both sides by 76.05. And so the rate is equal to, oh, by the way, right, if it's going to be a percent, we're going to want to multiply by 100%. So we get 27.13 divided by 76.05. And that is 35.6738. I've already multiplied by 100%. And so I'm just going to say approximately 35.7%. That's close enough. Okay? Now, it gets a little trickier. Now, the average community college tuition and fees were what percent less than the 4-year institution's tuition and fees? So now it wants you to compare how much less it was. So, it's still basing a comparison on the 4-year institution's average tuition and fees. So this is still the base. Less than, it's comparing it, what percent less than the 4-year institution's average tuition fee? So that's still 76.05 is still our base. But now they want to know what percent less than. So we could take the amount to find the percent less than, the percent less than, we need to know the amount, the absolute less than, basically, the amount less than. So what do we have to do to find the percent less than? Is we have to subtract 76.05 minus 27.13. Which is 48.92. So that is our amount less than. So remember, if R times B equals A, if I want the rate or the percent less than, I need to know the amount less than. And our base is 76.05, and that's 48.92 is R. And so we do the same thing again. We're going to divide both sides by 76.05. And then multiply by 100% when we change it to a percent. And so 48.92 divided by 76.05 is 0.643 times 100 is about 64.3%. Notice you could have just subtracted 35.7 from 100. Another way to do that is 100% minus the 35.7% also gives you, if you add a 0, that gives you 3, and then 10 minus, that'd be 9 minus 5 would be 4, and then 9 minus 3 would be 6. So that gives you the same thing if you just subtract. If the lower amount's 35.7% of the bigger one. There's a 64.3% difference. Now, let's read this next one. It says the average in-state tuition fees at a four-year institution was what percent more than the average tuition fees at a community college? That sounds similar. However, on this one, it wants what percent more it is. So this is, we still have to find the what percent more than something, we need to know the amount more. Well, we already know that it was 48.92 was the difference, right? We already knew it was 48.92 more. But what's the difference between this and the previous problem is what's after the than. The base in this one is the community college's tuition and fees, which here the base is equal to 2713. So the rate times the base is equal to 48.92. And now when you solve for that, we divide by 2713. Oops. And of course multiply by 100%. And so we get 48.92 divided by 2713 times 100, percent sign. That gives me 180.3% approximately. Okay, so that's how you'd find those. Pretty straightforward. Okay, now we're going to talk about percent change versus percentage point change. So in an efficiency rating, first of all, a percentage point change is not the same as a percent change. I would say that the percentage point change, a good way to think of that is it's an absolute change, but it will have a percent sign. It's using a percent measurement. So you only have a percentage point change if what you're talking about in the first place is a percent measurement. So we have percent measurements in things like interest rates. When interest rates go from, let's say, 8% to 9%, that would be called a 1 percentage point raise, not a 1% raise. 1% of 8% is only 0.08%, so it will only increase from 8 to 0.08. But a 1 percentage point raise means if you start out with some percent, you add that percentage point onto it. So there's a big difference between a 1% raise and a 1 percentage point raise. So in this case, if something increased from 40 to 50, that's a 10% percentage point increase. Okay? That's we call it, I should just say it's a 10 percentage point, there shouldn't be a percent sign there. It's a 10 percentage point increase. Now, that's not the same as the percent increase. That would be 10% out of the base, the beginning 40%, which is 1/4 or 25% as a relative increase. Okay? So this would be just a 10 percentage point change, but 10 percentage points out of 40 is 25%, which would be a relative increase. So let's look at this. It says a research center increased its solar cell efficiency by 0.75 percentage points. And that means it went from 17.5%. You add directly 0.7 percentage points. So you add on 0.75%, and that gives you 18.25%. Now, that is the amount of increase is a percentage point amount. So if you use rate times base is equal to the amount of increase, that's the absolute increase, is 0.75 percentage points. The original base is what? 17.5%. And so to solve for the rate, we're going to divide by 17.5%. I want you to notice what happens here. The percents reduce out. And we're left with R is equal to Now we're going to have to convert this to a percent, so we have to multiply that by 100% because we lose our percent signs here when we reduce it. So we get 0.75 divided by 17.5, and that is 0.04, but if you round off to the nearest tenth, that's going to be about 4.3%. Now that's the relative change from 17.5 to 18.25 is a 0.725 percentage points, and that's a 4.3% relative change. And that's all for now.